Yesterday we had learned about the vertex form that said y equals a times x plus h squared plus k. The great benefit to the vertex form is how easy it is to find the vertex. It just comes from these two numbers. The h will tell us what the x coordinate is. Now the x coordinate is not going to be h, it'll be the opposite of h. It'll be that value that will make x plus h equal to 0. But that k that's at the end, that will be the y-coordinate of the vertex. So yesterday we had talked about graphing parabolas that are in vertex form. So let's run through one of them real quickly. First of all, identifying which way it opens, that's going to come from this -1. Because it's negative, it will open down. The vertex is super easy to find because we saw that before. These will give us our coordinates of the vertex being at +2 and +1. So the axis of symmetry is a vertical line passing through the vertex, x equals +2. So far, I have the point 2, 1, and that the parabola is going to open down with an axis of symmetry passing through x equals 2. Now, to find the y-intercept and the x-intercept, what we have to do is let the other one equal 0. So what I mean by that is when I want to find the y-intercept, I let x equal 0. So y is going to equal -1 times 0 minus 2 squared plus 1. Now you can let your calculator do that, but -2 squared is going to be 4, and -4 plus 1 would be -3. That means that our y-intercept is going to be right here at -3. Then, to find the x-intercepts, we're going to let y equal 0. So 0 is equal to -1 times x minus 2 squared plus 1. I'll subtract 1 to get this one onto the other side. Then divide both sides by -1 to get rid of this coefficient. Undoing the square through square rooting gives me that x minus 2 is equal to plus or minus 1. And now we add 2 to both sides. So 2 plus 1 is 3. 2 minus 1 is 1. So those will be our two x-intercepts at 1 and 3. Using that axis of symmetry, I can find the mirror image of this y-intercept at -3. Since it's 2 steps away from the axis of symmetry, I'll take another 2 steps to find that other point. And now I have enough to come up with a really great parabola. And there we go. There are a lot of benefits to using vertex form, mainly that it is a lot quicker to graph and a lot easier to find all of those points. But today I want to really focus on how do we take a parabola that's written in standard form and turn it into vertex form. Well, in order to do that, what I have to do is to complete the square. So my very first step is going to be just to kind of get this part alone so that I can complete the square. To do that, I'm going to take the 5 and move it over to the other side by adding 5. It's just going to sit there temporarily while I complete the square. In order to complete the square, I have to figure out how much to add. And that's going to come right off of this 6. We take half of 6, which is 3, and square it. That'll give me that constant. Because I added 9 to the left, I have to add 9 to the right as well. Now my equation is sitting at y plus 14 is equal to a perfect square, x plus 3 squared. So to finish it off, I'm just going to get y alone, and y will equal the x plus 3 squared, and to get y alone, I'll have to subtract that 14. So minus 14 at the end. Now the equation is written in vertex form. Now that problem isn't too difficult when we have a leading coefficient of 1. However, when it changes so that now we have a leading coefficient of -2, we have to take that into consideration. Again, I am going to start by separating out that negative 5 and bringing it over to the other side. So I'll have y plus 5 is equal to. On the right hand side, I also have to get this ready to complete the square. I can't complete the square with a leading coefficient of negative 2, so I'm going to factor that out by bringing it out in front of my quadratic. Dividing out a negative 2 from the negative 2x squared term leaves me with x squared. Dividing out a negative 2 from the positive 8 term leaves me with negative 4x. Now I'm ready to start completing the square. To do that, I have to figure out how much I want to add right here. Again, we key off of the linear term, that negative 4 and the negative 4x. Take half of that, negative 2, and square it. Gives me 4. Where we have to be careful is really recognizing that I didn't just add 4. We need to add the same amount over to the other side, but that amount is not 4. It looks like 4 because that's the number that's in this blank. However, we need to recognize that we took this negative 2 and that's going to get distributed throughout the entire quadratic. So we really added a negative 8. This negative 2 times the negative 4 is negative 8. Now when we simplify, we have y minus 3 is equal to negative 2 times x minus 2 squared. To finish things up, we just add that 3 back to the other side. And y is equal to negative 2 times x minus 2 squared plus 3. And there's a good quadratic in vertex form. This last problem seems a little bit difficult the first time you read it. However, it's not as bad as it looks. It says to write the equation of the parabola with a vertex at 3, 2 that passes through the point negative 1, negative 2. Well, since we're going to write the equation of a parabola when we're given the vertex, we should probably use vertex form. Now, knowing that the vertex is 3, 2, I'm just going to plug those values in where they go. So currently I have y is equal to a times, since the x coordinate is 3, this will be x minus 3. And since the y coordinate is 2, this will be plus 2. The last thing that we need to figure out is what this a is going to be. We'll get that from the point -1, -2. However, that doesn't directly tell us what a is. What -1 and -2 are x and y coordinates. So in the function that I do have a y coordinate, and I am given an x coordinate. So I'm going to plug those two values in where they go. The y coordinate is -2 and the x coordinate is -1. Now I have an equation that only has one variable in it, and that's the variable we need to solve for. So on the left I have -2. A is getting multiplied by -1 minus 3 squared. So -1 minus 3 is -4. When I square that, I'm left with 16. Now, to solve, we'll just subtract 2 from both sides. Be careful, don't think that that's equal to 0. It's actually -4 is equal to 16a. These two cancel. Then we'll finish it up by dividing both sides by that 16. So a is going to equal -1/4. This is what a is. It's not the equation, it's what a is. So that has to go back into our equation for a. And then we can finish up writing everything out. Y is equal to a, -1/4, times x plus h, so that'd be x minus 3 squared, plus k, in this case 2. And there we have the equation of the parabola with the vertex 3, 2 that passed through that point, -1, -2.